Enhanced grip. Enhanced grip is one of the most underrated advantages your fingerprints provide. Those raised ridges increase friction between your skin and objects, helping you hold things securely whether gripping a wet glass or climbing a rough surface. The traction from these ridges prevents slipping in ways smooth skin simply cannot. Your fingerprints create a sophisticated friction system that adapts to almost any condition, from dry climbing holds to wet tiles. The ridges work in concert with your skin's flexibility, molding slightly around objects to maximize contact area. You can grasp delicate items without crushing them, or apply force to support your entire body weight on a narrow ledge. It's a mechanical advantage essential for early humans manipulating tools and climbing. Without fingerprints, our ancestors would have struggled to perform precise tasks or scale obstacles that other primates manage effortlessly. Moisture regulation. Moisture regulation within your fingerprints is the most hidden advantage most people never realize. Your fingerprints actively control hydration levels in your fingertips to maintain optimal friction regardless of conditions. When your fingers are dry, sweat pores become slightly blocked and your body activates sweat glands to provide just enough moisture for grip. When wet, fingerprint ridges act as microfluidic channels, moving excess fluid away through grooves while maintaining moisture where it matters. This dual mechanism system represents one of evolution's most sophisticated solutions. Research has revealed fingerprints manage moisture through capillary evaporation and sweat pore control, creating steady-state hydration in almost any scenario. Whether a climber faces a dry cliff or sudden rain, fingerprints automatically adjust to maintain grip. Rather than water creating slipperiness, the ridge system channels excess moisture away. This advantage gives primates manipulative abilities unavailable to other animals like bears or big cats, which lack this sophisticated moisture management. Touch sensitivity. Touch sensitivity is dramatically amplified by your fingerprint ridges in ways most people never consider. Those ridges don't just improve grip, they act as amplifiers for vibrations when fingers interact with surfaces, sending far more sensory signals to your brain. This heightened sensitivity allows you to feel textures, detect fine details, and perform delicate tasks like writing or sewing. The ridges are precisely tuned to frequencies that specialized nerve endings called Pacinian corpuscles detect. Research revealed ridges amplify exact vibration frequencies these receptors respond to, suggesting fingerprints channel these precise vibrations to sensors beneath skin with remarkable efficiency. The tiny grooves aren't random. They're shaped by evolution to match your nervous system's sensitivity thresholds. When you pick up fabric, the ridges translate texture into vibrations your brain interprets instantly. This sensory feedback is so refined you distinguish between different materials without looking. Your fingertips become sophisticated biological sensors, providing constant information about your environment, helping guide your hands with precision. Uniqueness. Uniqueness is perhaps the most fascinating hidden advantage of fingerprints, though it operates on a different level than grip or sensation. No two people ever have the same fingerprints, including identical twins who share identical DNA. This absolute uniqueness has profound implications. Your fingerprints form through an intricate interplay of genetic and environmental factors during fetal development, beginning around the 3rd month and fully forming by the 6th month. Genes determine the general characteristics of your pattern type, but environmental factors create slight differentiations that make each fingerprint completely distinct. The exact arrangement of ridges, minutiae, and identifying features emerges from a Turing reaction diffusion system involving molecular nailing between EDAR, WNT, and antagonistic BMP pathways. Fingerprint patterning begins from variable sites within each finger and expands in waves throughout the digit. Variations in location, timing, and angle of wave initiation, combined with interactions between waves from different sites, create the vast variation you see in the human population. This means your fingerprints are a record of your individual developmental history, a biological signature that no other person possesses. This uniqueness provides evolutionary advantages beyond identification. It suggests fingerprints may help your body recognize self from other, or coordinate fine motor control in ways specific to your exact physiology. Permanence. Permanence, also called persistence, represents another crucial hidden advantage most people overlook. Your fingerprints remain essentially unchanged throughout your entire lifetime. As new skin cells constantly form and replace old ones, they remain cemented in the existing friction ridge and furrow pattern established before you were born. This permanence provides stability and continuity to your fine motor abilities and sensory feedback system. Even attempts to remove or damage fingerprints are ultimately thwarted when new skin grows back. Unless damage is extremely deep, the new skin cells will regenerate following the original pattern. If damage is severe enough to disrupt the pattern, the new arrangement caused by the injury will persist and remains unique to you. This means your body has evolved a system that protects one of its most valuable adaptations. Your fingerprints are essentially permanent, securing your fine motor capabilities across your entire lifespan. This permanence allowed humans to develop increasingly sophisticated tool use and manipulation skills that persisted from childhood through old age. Unlike other skin features that change and fade, fingerprints remain as stable anchors for your interaction with the physical world. This consistency across decades provides a biological foundation for learning complex manual skills that would be impossible if your sensory and mechanical fingerprint system changed throughout life. Pattern diversity. Pattern diversity across human fingerprints creates populations optimized for different environmental and occupational demands. While all fingerprints share the basic ridge and furrow structure, the actual patterns vary widely among individuals. Some people have loops, others have whorls, still others have arches. These different pattern types may reflect subtle variations in how evolution optimized fingerprint function for different tasks and environments. Loops might provide advantages for certain gripping styles or fine motor tasks. Whorls might offer different sensory amplification patterns. Arches might optimize differently for pressure distribution. This diversity means humanity developed a population-level advantage where different individuals possessed fingerprint variations slightly better suited for different activities. A surgeon might have fingerprints optimized for extreme fine tactile sensitivity. A climber might have ridges structured for maximum friction and moisture control. An artist might possess fingerprints that provide superior vibration detection for detailed work. This isn't rigidly determined, but rather represents the subtle variations that emerge from your unique developmental history and genetic heritage. The pattern diversity across all humans creates a species-level advantage where we collectively possess variations on an optimal design, each slightly tuned to different needs and environments. Have you noticed how your fingerprints feel different on various surfaces? Let us know in the comments and subscribe for more fascinating videos about the hidden advantages hiding right on your body.